Good morning, class. Welcome back. If you check out the notes on the board behind me, the best part about today's notes is you don't have to take them. We're just getting started here. We're just getting warmed up in our 2020-21 school season. Welcome back. If you got up this morning in Pacifica, California, you probably noticed, depending on where you were, ash on top of cars, on top of sidewalks. You've got ash falling from the sky. One of the things in current events today that if this was a class and we were sitting down taking notes, or if it was the regular school season starting up already in your notebooks, we would talk a little bit about fires in California. We had a bunch of lightning strikes the other night. You might remember that. A couple of nights ago we had a great lightning storm. Unusual for us. We get one maybe once a year around here. But the fires that were caused by that lightning kind of merged together into some larger fires around here. And the fire season in California has been getting longer. So in current events, again, we talk a little bit about the science of California, but usually in California we have a fire season that runs roughly from about the beginning of August through about mid-November. The fire season in California has been getting longer. If you check out the changes in our fire season, mainly our climate is getting warmer. We'll talk about the why of that in a little bit. But we know from, for example, studying tree rings and doing observations up in the High Sierra that California is prone to very long droughts, and we've had some droughts that have historically lasted in some cases for dozens of years. So we'll talk about how we know that. But right now we're dealing with fires and ash falling from the sky outside. Quick thing I want to show you right here. See how I've written the notes today in cursive? I don't always use cursive. Sometimes I just use lowercase. But as we get ready for the school year, I tend to use lowercase or cursive. But when you see something written in capital letters, particularly when it's in capital letters and is underlined, take a moment to define those. Take a second to say, hey, that must be important. Those are what I call key terms, what the book calls key terms. And make sure when you see something that's written in capital letters, and I'll always point them out too, but capital letters means go look it up. Make sure that you know what it means. You can obviously Google it nowadays. Google has become a verb, and you can check out the definition online. Back in my day, we used to use these things called dictionaries. Used to carry one around all the time and make sure that we knew. This particular one is a dictionary of math terms, but when you check out keeping a dictionary handy, or just making sure that you Google capital letters, capital letter terms when they come up, that's going to be important in this class. One thing I want to talk about today that we're going to spend our first week on, there's a lot of experiments we can do from home. I'm going to take you on the road out here in a second, well, on the road outside the classroom anyway, and we're going to do our first science experiment from home. Simple one. All the experiments this year that we do online are things that you can hopefully repeat at home. Keep it really simple in terms of materials, but really deep in terms of the learning that can come out of it. So check out the first one. Observation skills. Observation skills for a scientist are probably the most important thing. The book down there. If you check out one of, I would say, the top 3 most important books in the history of science right here, Charles Darwin, The Origin of Species. Darwin on his ship, the HMS Beagle, we're going to talk a lot about that this year, used observation skills to absolutely rewrite and create the entire field of natural selection and evolution by natural selection. Observation skills are far and away the most important skill that a scientist can have. For example, Fleming and the discovery of penicillin. Many of us have had to take penicillin for all kinds of reasons. Maybe an ear infection when you were little, maybe a dental infection or something like that. If you end up taking penicillin, this is the result of a discovery in 1928. Again, we'll go through this in class. These aren't formal notes yet. You don't have to write anything down. But really, almost an accidental discovery. Fleming, a scientist in England, was doing an experiment, and he noticed that a penicillium mold, it's a fungus really, when it was growing close to bacteria that was in essentially a petri dish, these little dishes where you grow samples, he noticed that everywhere that the fungi and the fungus was touching the bacterium, the penicillin was killing the bacteria. This led to an antibiotic. This was the first ever used antibiotic that was able to kill bacteria and thereby prevent a lot of people of dying from what we used to call simple, if you will, infections. A lot of people might not have made that observation, but he had the presence of mind to say, hey, well, that's strange. I'm looking at something different. So let's go check out an observation, something that we can do ourselves. Wherever we are at home right now, we can do it. So I'm going to grab from my desk over here a piece of chalk. I'm going to grab my iPhone, be a little clunky. I'll work on the editing later. And let's take a walk outside the classroom, around the corner right here, and piece of good old chalk right here. You can use sidewalk chalk if you have it handy. As we walk outside, also look at the color of the sky out here. It tends to be a little bit red today because we've got a lot of smoke in the air. It kind of changes the appearance of the sky. We'll talk a little bit about that, but you've got more red light getting through than you've got the blues or the greens. But our observation that I'd like you to do today is simply this. So I walk onto your schoolyard. You see a basketball court behind me. Unfortunately, not getting a lot of use these days. But if you check out the basketball court, I'd like you to do two things, please. One, note the time. So I'm gonna look right here. It's 9:10 on my watch, just about. And on a piece of paper somewhere, note the time, and I'm gonna mark the extent to which the shadow of that basketball court reaches. In other words, I'm gonna just go take my piece of chalk, I'm gonna go over here, and I'm gonna write down a line on the ground right across. And I'll put a piece of chalk here so you can see it. And if you can see that behind me, I'm not sure if you can see my hand here, the extent, how far does that shadow reach? And I want you to make not only an observation, at 9:10 on August 19th, this is where the shadow reached. I'd also like you to make a prediction. If I were to come back tomorrow, or the next day, or a week from now, at the exact same time, 9:10 in the morning, would the shadow be longer, would the shadow be shorter, or would it have no change at all? So there's your first challenge. Again, you don't have to write this down. We're just getting started here. But I do want you to think about observation skills. If you don't have a basketball court and a piece of chalk handy, take a rock and a stick. Take the shadow from the height of a building nearby. Take the shadow from a tree that's someplace and put something in the ground to mark where it is at a certain time of day. We're going to come back, we're going to check it out, we're going to see what changes over the next couple of days. And we want to talk about, why is it growing? Why is it getting shorter? Or why is it staying the same? Have a great day, everyone. Looking forward to seeing you 178 more times, I think. Take care. Bye-bye.